Welcome children. So today we will see oscillations part 1. So we will do a quick revision of formulae in SHM chapter. So SHM chapter, so we also call it as oscillations. So this is part 1 because in SHM so we have so many formulas. All these formulas have been divided into different videos. Now this is the first part. This is the first video. Now to understand these oscillations, we need to understand what is periodic motion and what is oscillatory motion. What is periodic motion? See children, if any motion gets repeated after regular intervals of time, then it is called periodic motion. For example, circular motion. Planets will be revolving around the sun in circular orbits. So, for example, Earth will be revolving around the sun, and what the time period of that revolution? It is 365 days. After every 365 days, so the Earth will be repeating its motion. So it is periodic motion. Even pendulum, the oscillations of the pendulum, even that is also periodic motion. Electrons will be revolving around the nucleus. So electrons will be revolving around the nucleus in circular orbits. Each electron so will describe periodic motion. These are the examples of periodic motion. Now, let us understand what is oscillatory motion. Oscillatory motion is a to and fro motion. To and fro motion means, so that is the particle should retrace its path. For example, simple pendulum. So when you pull the simple pendulum aside, away from its equilibrium point, then it will oscillate. So what do you mean by this oscillation? To and fro motion. To and fro. That means in half of the time period, it will travel in one direction. In the remaining half of the time period, it will travel in the opposite direction. To and fro. That means the particle should retrace its path. If the particle retraces its path, then it is called oscillatory motion, to and fro motion. Children, by default, all oscillatory motions are periodic. All oscillatory motions are periodic. All oscillatory motions are periodic. But all periodic motions are not oscillatory. For example, revolution of planets around the sun is not oscillatory. That is, the earth will not be revolving like this, okay, to and fro. It will be revolving in the same sense. Even electrons also will be revolving in the same sense. So if it completes one revolution, let it be earth, let it be planet, or let it be electron. If it completes one revolution, the second revolution also will be done in the same sense. It will not be retracing its path. So all periodic motions are not oscillatory, but all oscillatory motions are periodic. Now we understood what is oscillatory motion and periodic motion. Now there is one more type of motion called vibratory motion. So what is vibratory motion? Vibratory motion is nothing but oscillatory motion with a high frequency. What is vibratory motion? Vibratory motion is nothing but oscillatory motion. Vibratory motion is nothing but oscillatory motion with a high frequency. So same oscillatory motion but with high frequency is called vibratory motion. We say atoms vibrate. In a solid, all the atoms vibrate. We don't say oscillate because atoms will have more frequency. Okay, so once we understood what is oscillatory motion, what is periodic motion, what is vibratory motion, let us see what are the causes for oscillation. What makes a particle to oscillate? See children, suppose the kind of force acting on the particle is F equal to minus kx to the power of n. If if n is equal to 3, that is the power of x is odd integer 1, 3, 5 and so on. If n is equal to 3, then what is the force acting on the particle? Minus kx cubed. Now I place that particle at x equal to 0. At x equal to 0, the force is 0. At x equal to 0, force is 0. That is called equilibrium point or mean point. The point where the force is 0 is called equilibrium point or mean point. Generally, it is the midpoint of the path of oscillation. Now at x equal to plus 1, that means I bring that particle to plus 1 or plus 3 or anything. So when here I bring the particle to x equal to 3. So that means if I bring the particle, so if I place the particle at x equal to plus 3, at x equal to plus 3, what is the force acting on the particle? Minus k is constant. So 3 whole to the power of x equal to 3 whole to the power of 3. So that is F is equal to minus k. So that is so 27, k into 27, that is equal to minus 27k. See children here, if force is negative, that means when I bring the particle to x equal to 3, then what is the force acting on the particle? Minus 27k. If the force is negative, then it will be directed towards the negative x-axis. If the same particle, if I place at x equal to minus 3, that is if I place at x equal to minus 3, if I place the same particle at x equal to minus 3, what is the force children say here? So if I bring the same particle at x equal to minus 3, force will be equal to minus k minus 3 whole cubed. Now I will get minus k. This will be minus 27. Minus 27. It will be plus 27k. That means the force acting on the particle on the negative x-axis will be towards positive x-axis. Now it will be directed towards right. So on the positive x-axis, the force will be leftward. On the negative x-axis, the force will be rightward. Because so if F is positive, the force will be rightward. If F is negative, the force will be leftward. Because of this kind of force, the particle will oscillate about the main point. The particle will oscillate about the main point. Now, in the same situation, suppose if we have F equal to minus kx square, F equal to minus kx square, then we have to see whether the particle oscillates or goes in a straight line. If the force is F is equal to minus kx square, and if we place the particle at same x equal to 3, okay, now let us see children here at x equal to 3, at x equal to plus 3. So what is the force acting? F is equal to minus k into 3 whole square. So that equal to minus k into 9, that is minus 9k. That means force is negative, which means that the force will be directed towards left. So suppose if I bring the particle at x equal to minus 3, at x is equal to minus 3, the force will be F equal to minus k minus 3 whole square. Now this is minus k into plus 9, that is minus 9k. That means on the positive x side, the force is negative. On the negative x side also, the force is negative, which means that the particle goes in a straight line. It will not come back. It will not retrace. So, what we understood now? What are the causes of oscillation? Which kind of force will oscillate, will make the particle to oscillate? Now we understood. If the power of this x is, if the power of x is odd, that is F is equal to minus k x to the power of 1, F equal to minus k x cubed, F is equal to minus k x to the power of 5, F equal to minus k x to the power of 7. For all these kinds of forces, whichever force, so out of all these forces, whichever force acts on the particle, then it will perform oscillations. Among all these oscillations, which is the simplest one? This is the simplest one. If this kind of force acts on the particle, that is the simple, which is the simplest force, minus kx power 1, that is minus kx. Then that simple oscillatory motion is called simple harmonic motion. So what is simple harmonic motion? This is the simple harmonic motion. If the kind of force acts on the particle, if the kind of force acting on the particle is so is directly proportional to minus x or minus kx. If that kind of force acts on the particle, then that simple oscillatory motion is called simple harmonic motion. Okay, children, you understood what is simple harmonic motion. Now, this is simple harmonic motion. This should be the kind of force acting on the particle F equal to minus kx. And if we substitute F equal to ma, then if you calculate A, then this is what you get A equal to minus k by m into x. So, what is the condition of SHM? F should be directly proportional to minus x, or A should be directly proportional to minus x power 1 actually here. If the force acting on the particle is directly proportional to negative of the displacement from the mean point, then it is called SHM. Then it becomes SHM. Either force or A. Now, what is the differential equation of SHM? This is the formula for differential equation of SHM. How we get this differential equation of SHM? Just now we have seen A is equal to minus k by m into x. A is nothing but d square x divided by dt square. So I bring this minus k by m so k by m into x this side plus k by m into x equal to 0. Remember children here k equal to m omega square, where m is the mass of the particle, omega is angular frequency. We are going to see this formula later. Now d square x by dt square plus m omega square divided by m into x equal to 0, m will be cancelled, and d square x by dt square plus omega square x equal to 0. This is how we got this formula. Remember children, this formula is very, very important. Problems will be asked on this formula. How problems will be asked in this formula? They will give a differential equation and you will be asked to calculate time period. What is the formula for time period? So 2 pi by omega. See children here. One example we will do that. Find the time period of given SHM. This is the differential equation of SHM. Compare this differential equation of SHM with the standard one, d square x by dt square plus omega square x equal to 0. If we compare, what is the coefficient of x here? Omega. Omega square equal to 4, omega equal to 2. So now the time period of SHM is 2 pi divided by omega. That is 2 pi divided by 2, that equal to pi second or 3.14 second. Children, time period is equal to 2 pi by omega. Time period of SHM is 2 pi by omega. What is omega? Angular frequency. So about angular frequency, about general equation of SHM and all that in the next video we'll see in detail. Now this is part 1. So thank you children.